Water is probably the most important compound on Earth. Some of the reasons are because of its properties. The first property we will be investigating is the boiling and melting points of water. But before that, let's make sure we understand some vital information. Elements like to have a full outermost shell of electrons. To do this, elements bond with other elements. The amount of atoms an atom will bond with depends on the valency of both of these atoms. For example, sodium has a valency of +1. It can join with chlorine to make sodium chloride, or table salt. This type of bond is called ionic bonding and is done so with a metal and non-metal. The other types of bonding are covalent, hydrogen, dipole-dipole, and metallic. Covalent bonding occurs between two nonmetals, for example, water. In this bonding, electrons are shared rather than being given away. Dipole-dipole bonding occurs when molecules are polar, which is caused by strong forces acting upon electrons. The force which acts upon electrons is called electronegativity. Should it outweigh that of the other atoms in a compound, the atoms become polar. Dipole-dipole bonding occurs in other words, between molecules. This table shows the electronegativity of elements. The molecules are arranged so that the positively charged atoms are next to negatively charged atoms from other molecules. So in water, an oxygen atom would be surrounded by hydrogen atoms rather than oxygen atoms, as they are negatively charged and repel each other. Hydrogen bonding occurs between molecule elements such as fluorine, nitrogen, and oxygen have very strong electronegativity forces. The oxygen, nitrogen, and fluorine atoms have such a strong force that the hydrogen atom becomes slightly attracted to the fluorine, nitrogen, or oxygen atoms found in other molecules. Hydrogen bonds only occur when the electronegativity forces are very strong. So, ammonia, which is nitrogen and hydrogen, would have hydrogen bonds, whereas hydrogen sulfide would not. So, getting back to the boiling and melting points, compounds with hydrogen bonds have higher melting and boiling points, as more energy is needed to move or separate the molecules. When water boils at 100 degrees, the hydrogen bonds are dipole bonds are broken. At 0 degrees, water is melting from ice to water. Water actually increases in size as it freezes because the molecules move into a fixed or ordered position, like a lattice. This means that the molecules actually move away from each other, causing the density of the ice to be slightly less than that of water. Refer to the videos at the end. The second property of water we will be looking at is viscosity. Viscosity directly relates to the particle size and the strength of forces located in between particles. Viscosity can be defined as how a substance floats. Due to strong hydrogen bonds, the viscosity of water is fairly high, although it is not as great as honey or vegetable oil. The viscosity of water is high because the hydrogen-bonded molecules have to move. In this case, a coin is used to show how quickly or slowly the molecules move. This diagram represents what happens with viscosity in between intermolecular forces. Lastly, surface tension is an important property of water. If you have a 250 milliliter beaker of water and fill it, you will notice that more water can be added and that it will not spill. If you were to only fill a beaker up halfway at the places where the water touches the beaker, the water level is not flat, but rather in a U shape. This is due to surface tension. As water is in a liquid state, the intermolecular bonds are quite strong. The molecules at the top would only be bonded to molecules beside or below it, whereas molecules in the middle are bonded everywhere. Due to water molecules having such strong bonds, they create almost a skin around the surface, which allows for the top area of water to be able to stay without spilling.